Okay, so a manufacturer makes chocolates and he claims that there is an average of 85 per packet. Tala bought 30 of these packets in order to check the claim. She found in her 30 packets that the sum of x, which is the sum of how many chocolates there are, was this, and the sum of x squared, which is, well, squaring all the x's, you get this. Part A, find an unbiased estimate for the mean number of chocolates per packet. Okay, the unbiased estimate for the mean is easy. It's just this 2506 divided by 30. It's the total over 30. It is an unbiased estimate. The mean of the sample is an unbiased mean for the full population. So this is, and let me get my calculator out, 2506 divided by 30 gives me 83.5333. 83.5333. Okay, so it's worth just thinking at the moment that he's saying there's 85 per packet, and Tala's saying there's that. Well, that's his average of his sample, so still may be fine, but it's worth noting. You can put that to 3 significant figures if you want. Okay, B. He then says use this formula, so he gives you the formula. That's nice. To get an unbiased estimate for the variance. So it's the sum of x squared, which is this. It's 209,738 minus the sum of x squared, which is 2506. Well, 2506 squared over n, which is 30, because there's 30. It's a sample of 30 bags, and then n minus 1 is 29, because 30 minus 1 is obviously 29. Okay, this I need to definitely use my calculator for. So it's 209,738 minus 2506 squared over 30, all over 29. And this gives me 13.9126. 13.9126. Okay, good. Part C. Find a 95% confidence interval for mu. You may assume that all conditions for a confidence interval have been met. Okay, so confidence intervals. We need to go to menu, statistics, confidence intervals. And here I have to choose between the Z interval and the T interval. The Z interval is when you know the variance, the population variance or the population standard deviation, and we don't know that. We have the sample variance, and we have an unbiased estimate for the variance, but we don't have the variance, so I have to use the T interval. Okay, my data input method is stats, because I have the statistics. I don't have any data. I don't have the numbers of chocolates. I just have the stats. I have the mean and the unbiased estimate for the mean, which is 83.5333. Put in the 6 numbers, guys. That's why I left them here. And then here, be careful. This is an unbiased estimate for the variance. We need the standard deviation. So I have to do control and this to get the square root. So it's 13.9126. And then n is 30, because there's 30 bags of chocolates. And this is my interval. The lower is 82.1405. So I can write it like this. 82.1405, is that what I said? 1405 and 84.9261. 84.9261. That 9261. That is the confidence interval. That is the 95% confidence interval. Did I click 95%? Yeah, I did. 0.95. Okay, so that's the confidence interval. And then he says, suggest with justification a valid conclusion that Tala could make. Right, so he's claiming, remember, you got to go back to this original claim. He's claiming 85% of the chocolates, 85%, sorry. He's claiming that there's 85 chocolates per packet. So Tala can conclude that there is not an average of 85 chocolates per bag, as 85 is outside the 95% confidence interval. Okay, done. Because think about it, look, what this means is she is 95% sure, going on all of this, that the average number of chocolates per packet is within this interval. It's between 82.14 and 85.92 or 3, whatever. But 85 is not in this interval. 85 is outside of it. So that's why I've written he's wrong. Well, he's not definitely wrong, but according to her test that she's run, this guy's wrong.